Hello everyone. In this lecture we are going to plot the image histograms. So histogram for an image is the graphical representation of the brightness distribution of a digital image, by which we means that the number of pixels versus the brightness value. So in the x-axis we'll be having the brightness value variations, and corresponding to one particular range, the y value will be having the number of pixels that are lying into that brightness range. Okay, so MATLAB offers a very simple function to plot the histograms, that is imhist, like other image functions, but the image supplied to it should be a single channel image only. Okay, then only be able to plot the graph versus brightness. Okay, so currently we have this 3-channel image in our regular path for lecture 1 of chapter 4. Now we are going to convert this into a single channel image so that we can plot the histogram. Okay, so for that we'll have to read this image first. We already know how to read an image, and we can convert this image into a single channel image like using a RGB to gray function. Say there are multiple ways to do this. Okay, now that we have got our single channel image, we can use this imhist function to plot its histogram. Okay, you can see that it is covering 256 values in the x-axis. So there are 256 possible variations in the brightness, and for each level of brightness it is showing the number of pixels that are achieving that. So for example, close to 50, the value of close to 50, there are around more than 200 such pixels which are having the value of close to 50. So here these are the most bright pixels, which are very less, and least bright pixels are also very less. Okay, so here you can see that this image is very dense because there are a lot of multiple vertical lines. The spacing is very less, so the total number of lines are called bins. Okay, currently the default value for this grayscale image is 256. So for every variation of single unit, it is giving us the number of pixels. If you want to change that, we can supply it in the second parameter. If I'll just say instead of 256, 128, then it is going to give me the histogram for every other value. Okay, for it will give the histogram for 0th, then 2nd, then 4th, then 6th, up to 256. For every other brightness value, it will give me the number of pixels. So this way, if we decrease bin's value, the image is going to be more spaced out, but it will have lesser information. Okay, so that's how we can plot the histogram of a grayscale image. If we want to plot the histogram of this RGB image only, then we can do this by separating out the channels and then plotting the histograms for each of the channel. Right, so we have already seen how we can separate out the channels. That is, R is equals to A, then colon 1. This will give me the R channel, the G channel similarly, and then B channel. We can use subplot, say 1, 3 to plot these histograms. For R we'll say imhist and R. Okay, title we can say R. Right, similarly we can copy this and do for G and B as well. 1, 3, 2, the second index, then G, then G. Similarly for B. Yeah, now that I have done it, we can see that it has plotted the histograms. So this is for R channel image, this is for G, and this is for B. This way we can plot the histograms for each of these channels. That's it. That's how we can plot the histograms. Goodbye.